In just 22 days, at least 22 strategic bridges were reportedly targeted along the supply network connecting Donbas, southern Ukraine, and Crimea. That number does more than show the intensity of a new campaign. It also raises a much more serious problem for the Russian military. An army may still have tanks, artillery, and tens of thousands of soldiers on the battlefield, but its combat power can decline quickly if fuel does not arrive on time, ammunition remains trapped far behind the front, and entire convoys are forced onto narrow roads already being watched by Ukrainian drones. For years, Moscow has built a large logistics network stretching from Russian territory through Donbas and the coastal corridor, then continuing into Crimea. Every day, this system must carry fuel, artillery shells, spare parts, engineering equipment, and reinforcements to support Russian operations across several areas of the battlefield. But that network is only strong as long as its main connections remain open. What happens if Ukraine is not simply attacking individual bridges, but is trying to turn the entire southern supply network into a chain of military bottlenecks? Why are Donbas, southern Ukraine, and Crimea all appearing inside the same campaign? And can Russia keep its supplies moving as more routes behind the front come under pressure? Stay with Military Force as we examine what is happening. Ukraine's bridge strikes across Donbas, southern Ukraine, and Crimea point to a wider campaign against the system that keeps Russian forces supplied. The targets are separated by long distances, but they belong to the same military network. Supplies move from Russian territory into Donbas, then pass through the coastal corridor near Mariupol and Melitopol before reaching distribution routes that support Russian units in Kherson, Zaporizhia, and Crimea. This chain carries fuel, artillery shells, replacement vehicles, engineering equipment, and fresh troops. If one section slows down, pressure quickly moves to the next. Road and railway bridges are especially important because geography limits the number of safe crossing points. Rivers, canals, marshes, and soft ground can block heavy military traffic. Tanks, self-propelled guns, fuel trucks, and armored vehicles cannot simply leave a paved route and cross any open area. They need bridges strong enough to carry their weight and roads wide enough to support continuous movement. This is why a bridge does not need to collapse completely to create a serious military problem. Even limited damage can force traffic into one lane, reduce speed, or stop heavy vehicles while lighter traffic continues. A short delay can grow into a long queue when hundreds of trucks are moving toward the same front. That congestion can expose entire convoys. Once vehicles gather in one place, they become easier to detect from the air and harder to protect. It can also disrupt planned operations. Ukraine appears to be using this pressure to make Russia spend more time and resources on movement rather than combat. Longer routes consume more fuel. Extra checkpoints slow delivery. Additional escorts reduce the number of troops available elsewhere. Air defense units must cover roads, railways, and crossing points instead of focusing only on military bases. Engineering teams also have to remain behind the front to inspect damage, clear debris, and keep traffic moving. The success of this campaign cannot be measured only by the number of bridges destroyed. A damaged crossing may be repaired, and a closed road may be replaced by another route. The more important question is how much delay each strike creates, how many vehicles are diverted, and how many Russian units must be reassigned to protect the supply system. If those costs continue to rise, the effect may reach far beyond the bridges themselves. Ammunition may arrive later. Fuel reserves may fall. Commanders may reduce movement to avoid further losses. The pressure can spread from the rear area to the front line without Ukraine needing to defeat every Russian unit directly. To reach bridges located deep inside Russian-controlled territory, however, Ukraine first had to create gaps in the surveillance and air defense network protecting Crimea. Before the bridge strikes, Ukraine appears to have targeted electrical infrastructure linked to northern Crimea and the Jankoy area. This sequence suggests that the operation may have been designed in layers, with the first stage intended to create confusion inside the Russian defensive network before the main weapons approached. Electrical substations are not radar stations, but they can support the wider system around them. Air defense units depend on power for communications, data links, command posts, maintenance areas, and nearby facilities. Many military systems also have backup generators, so a power cut would not automatically blind the network. However, switching to emergency power can slow coordination and force crews to manage several problems at once. That matters during a coordinated strike. Even a short period of weaker communication can affect how quickly radar operators identify targets and how fast commanders assign weapons to intercept them. Ukraine did not need to shut down every sensor. It only needed enough uncertainty for some drones or missiles to move deeper into defended territory. The next stage focused on the Ichki railway bridge, which formed part of the internal distribution system inside Crimea. It helped connect cargo arriving from the Kerch direction with Jankoy, one of the peninsula's main railway centers, before supplies continued toward Russian forces farther south. Railways carry special value in military logistics. One train can move large amounts of artillery ammunition, fuel, armored vehicles, and engineering equipment in a single journey. Roads can replace part of that capacity, but doing so requires more trucks, drivers, fuel, and travel time. A damaged railway bridge therefore creates pressure beyond the structure itself. The loss of rail capacity can also disturb military timing. Ammunition may arrive later than planned, heavy vehicles may wait at loading points, and commanders may have to change the order in which units receive supplies. Even if the bridge remains partly usable, inspections, speed limits, and repair work can reduce the number of trains passing through each day. The Azovsky Road Bridge served a different role. It supported traffic along the land corridor used by fuel tankers, cargo trucks, military escorts, and engineering vehicles moving between occupied southern Ukraine and Crimea. The surrounding geography increased its value because rivers, wet ground, and narrow approaches can limit where heavy vehicles are able to cross. Damage to this bridge would not stop every vehicle, but it could reduce the speed and volume of movement. Heavy trucks might be forced onto longer roads, while military police would need to control traffic and give priority to urgent cargo. Fuel tankers and ammunition vehicles could gather near the damaged crossing, creating delays and exposing the route to observation. Road transport is more flexible than rail, but less efficient for moving heavy loads over long distances. Replacing one train with many trucks increases fuel use, driver demand, maintenance needs, and congestion. Pressure on Azovsky could therefore make the loss of rail capacity at Ichki harder to manage. Striking Ichki and Azovsky at the same time created a problem across two transport systems. Russia could not transfer railway cargo onto roads without increasing congestion, while damaged road capacity made that shift harder. The result challenged efforts to balance rail and road movement. The timing forced Russia to divide its response. Repair teams, security units, and air defense assets could not concentrate on one location. Commanders had to decide which route was urgent and where equipment should go. This pressure could affect military planning. A delayed ammunition train may force units to reduce consumption. A fuel convoy held behind a damaged bridge may arrive after an operation begins. Heavy vehicles may be sent onto longer routes that are slower and easier to observe. The strikes therefore targeted timing and coordination as much as concrete and steel. Once the bridges were damaged, Russia had to send engineers, machinery, and temporary crossing equipment into areas already watched by Ukraine. Once fixed bridges were damaged, Russia had to restore traffic before delays spread through the supply network. That response created a new vulnerability. Bridge repair requires heavy vehicles, trained engineers, equipment, and long periods of activity in mapped locations. Pontoon trucks, cranes, excavators, transport vehicles, and repair crews cannot operate quietly. They must gather near the crossing, unload sections, clear debris, and prepare access roads. Some machines remain stationary for hours. In a battlefield watched by drones, this concentration is easier to detect than a convoy that is still moving. The repair site becomes part of the battlefield. The question is no longer only whether the original bridge can be restored, but whether the work can continue without exposing the people and equipment involved. Ukrainian reconnaissance drones can watch approach roads, identify new machinery, and follow the sequence of repair work. They can record where equipment is parked, when crews begin operating, and which temporary routes are being prepared. That information can then be passed to strike drones, artillery units, or other weapons in range. This creates a cycle of repeated pressure. The first strike damages the permanent bridge. Later attacks can target a pontoon section before completion, a crane while it is moving debris, or a temporary crossing after traffic resumes. The purpose is not always to destroy every machine. Ukraine can also slow the recovery process by forcing crews to stop, move equipment, or wait for air defense protection. Even limited interruptions can keep a route closed much longer than the original damage would suggest. Russia can reduce some of these risks, but every adjustment carries a cost. Engineering units may work at night to reduce visual detection, although thermal cameras can still reveal engines, generators, and human movement. Smoke can hide activity from optical sensors, but it may also slow the crews and signal that important work is taking place. Mobile air defense systems can be placed near the crossing, yet this removes them from other sites. Electronic warfare may interfere with drone control links, but it cannot guarantee that every aircraft will be stopped. Repair teams may also move equipment between several locations, which adds time and makes coordination more difficult. Russian commanders can build a bypass, move pontoon sections to another crossing, or divide convoys into smaller groups. These measures may reduce the damage caused by one strike, but they increase travel distance, fuel use, maintenance needs, and the number of personnel required to control movement. The greatest pressure may come from uncertainty. Engineers do not always know whether a drone is only observing or preparing another attack. Commanders must decide whether to continue working, pause the operation, or move valuable machinery away. Each delay may appear small, but repeated pauses can keep traffic blocked for days. Ukraine does not need to destroy every pontoon bridge or every repair vehicle. It can achieve a similar effect by making the work slow, dangerous, and difficult to organize. If Russian forces reopen one route only after several days, the supply problem has already influenced planning, fuel use, and the movement of urgent cargo. This contest is still a race between observation and recovery. Russia must inspect damage, bring in equipment, protect the site, and restore traffic. Ukraine only needs to detect each stage quickly enough to interrupt it again. Even if Russia succeeds in opening a temporary route on land, transport through the Black Sea and the Kerch Strait is facing pressure from another class of weapons. Ukraine has expanded its campaign beyond roads and railways by using unmanned surface vessels to challenge Russian control of the Black Sea. Systems such as Magura Vi-5 and C, Baby, give Kyiv a way to strike ships, ferries, port facilities, and coastal infrastructure without risking a naval force. These vessels are small, fast, and difficult to detect. Their low profile reduces the time available for Russian crews to respond, while remote guidance allows them to approach defended areas from several directions. Ukraine has also combined these attacks with drones and missiles, forcing Russia to protect ports, anchorages, and shipping routes. The effect has been wider than the loss of individual vessels. Russia has moved valuable ships away from Sevastopol toward Novorossiysk. This does not mean the Black Sea Fleet has abandoned Crimea completely, but it shows that Russian commanders now face greater limits when operating near the western Black Sea. Each ship moved away from Sevastopol creates longer travel times and adds pressure to Russia's coastal defense system. As ferry operations and maritime transport face repeated disruption, the Kerch Bridge carries a heavier burden. It is not only a military route, it also supports civilian vehicles, railway traffic, cargo trucks, and the movement of supplies into Crimea. That combination creates a traffic problem. Security checks can slow vehicles before they enter the bridge. Attack warnings may stop movement for long periods. Civilian traffic can compete with military transport for limited space. When one lane closes or inspections become stricter, long queues can form quickly. This weakens the bridge as a reliable military route, even when the structure remains open. A convoy that cannot predict when it will cross is difficult to include in a supply schedule. Fuel, ammunition, and replacement equipment may arrive later than planned, while vehicles waiting in line consume time and create security demands. The Kerch Bridge therefore becomes more than a crossing. It becomes a point where military needs, civilian movement, and security pressure all meet. Russia has built several layers of protection around the bridge. S-400 systems cover the wider airspace, while Panzer S-1 units are designed to engage lower-flying threats. Smoke screens can hide parts of the structure from optical sensors, and electronic warfare can interfere with satellite navigation or control links. Barriers and patrol craft are also used to block attacks from the sea. Ukraine, however, has been developing weapons that depend less on constant GPS access. Inertial guidance can keep a weapon moving after signals are disrupted. Image matching can compare the target area with stored visual data. Terminal recognition systems can help identify a bridge section or another fixed object during the final approach. These methods do not make Russian defenses useless. Air defense, smoke, electronic warfare, and physical barriers can still reduce accuracy and stop some attacks. Their importance lies in forcing Ukraine to use more complex systems and larger strike packages. The contest around Kerch is becoming a competition between defensive layers and guidance systems designed to work through interference. Russia must protect one fixed structure, while Ukraine can choose when and how to test that protection. As Crimea faces pressure from land and sea, Ukraine is also striking farther east to reduce the flow of ammunition, fuel, and reinforcements moving from Donbas toward the southern front. Ukraine's campaign in the east aims to reduce the flow of supplies before they can move toward the southern front. Road and railway bridges in occupied Donetsk and Luhansk connect Russian territory with routes through Donbas, Mariupol, and the coastal corridor. These crossings support the movement of artillery ammunition, armored vehicles, troops, and engineering equipment. Rail transport remains valuable because it can carry heavy cargo. Road convoys offer more flexibility, but they require more drivers, vehicles, and fuel. When a railway bridge is damaged, Russia may transfer urgent loads onto trucks, but that change increases pressure on roads and transport units. Strikes near Novoazovsk and on railway links in Luhansk matter because they affect routes serving multiple fronts. Their importance comes from their position inside a wider network, where cargo entering Donbas can later move toward Mariupol and southern Ukraine. Bridges control movement, but depots control what is available to move. Ukraine has also targeted storage areas where fuel, ammunition, spare parts, and other supplies may be held before distribution. A damaged route can delay cargo. A successful strike on a depot can remove part of that cargo from the system. Command and observation posts add another layer. These sites can help Russian units track convoy schedules, assign priority to urgent loads, redirect vehicles after an attack, and coordinate security around important routes. If a command point is disrupted, the road may remain open while the system using it becomes less organized. This combination creates several problems at once. Transport officers must find new routes, warehouse units must move supplies, and security forces must protect locations. Repair work must also be coordinated with traffic control so that military cargo does not become trapped near a damaged crossing. Ukraine is therefore targeting both the movement of supplies and the organizations responsible for managing that movement. The strike on the Slavyansky refinery in Krasnodar Krai extended this campaign beyond roads, bridges, and storage sites. Ukraine said the facility was hit during a wider series of attacks on Russian energy infrastructure. The refinery processes fuel in southern Russia, placing it within the economic and transport area that supports occupied territory and nearby military regions. A refinery strike does not automatically remove an equal amount of fuel from the battlefield. Russia can draw from reserves, other plants, and alternative distribution centers. The immediate effect depends on which units were damaged, how long repairs take, and whether production or loading operations were interrupted. Its military value lies in adding pressure to the beginning of the supply chain. Bridges affect delivery routes. Depots hold finished cargo. Command posts organize movement. Refineries help produce the fuel that enters the network. When these different targets are attacked during the same campaign, Russia must defend a much larger system. It must protect the source, the stored supplies, the transport routes, and the centers that direct them. As pressure spreads across every stage, the next question is how shortages and delays begin to change the behavior of Russian combat units. A modern army can appear heavily armed and still lose strength if fuel, ammunition, spare parts, and repair equipment do not arrive on time. Russian tanks and armored vehicles need constant fuel deliveries to move and support infantry. Artillery units depend on regular ammunition shipments because intense fighting can consume large stocks quickly. When deliveries slow, commanders may limit movement, reduce firing rates, or postpone operations. Even a temporary shortage can force units to protect equipment instead of using it when pressure is highest. The effects can spread across several formations. A tank unit without enough fuel cannot respond quickly to a new threat. An artillery battery with fewer shells must select targets more carefully. Infantry may receive less fire support during an assault or while defending exposed positions. Reserve forces can also take longer to move between sectors, reducing the ability of commanders to react to sudden changes. Traffic bottlenecks create another danger. Fuel tankers, ammunition trucks, and recovery vehicles may gather near a blocked route while waiting to move. That concentration makes them easier to detect from the air. If one vehicle carrying fuel or explosives is struck, fire and secondary explosions can damage nearby trucks and keep the road closed longer. Ukraine does not need to destroy every Russian supply route to create pressure. It only needs to make deliveries slower than the rate at which units consume fuel, ammunition, and spare parts. Once demand becomes greater than supply, shortages begin to shape military decisions. Russia has ways to respond. It can divide large depots into smaller sites, move cargo at night, increase road transport, and use alternative routes. It can also place air defense and electronic warfare systems near supply areas. These measures can reduce losses, but they require more vehicles, personnel, fuel, and planning. The result depends on which side can maintain its effort longer. Ukraine must continue finding targets and striking them before Russia restores normal movement. Russia must repair damage, protect the routes, and deliver enough cargo to prevent shortages from reaching combat units. This makes logistics a contest over time. Ukraine is trying to create delays faster than Russia can remove them. Moscow is trying to keep fuel, ammunition, and reinforcements moving before the pressure changes operations at the front. The central question is whether the wider network can recover quickly enough to meet the demands of forces fighting across several directions. No single bridge will decide the war, but a series of strikes against connected routes can change how an entire army moves. Each damaged crossing pushes traffic toward fewer alternatives. Those roads then carry more trucks, face tighter security, and become easier to monitor. Russia can repair bridges, build bypasses, and spread supplies across smaller locations, but every response uses more fuel, engineers, vehicles, and air defense. The real impact will appear in operational performance. Artillery units may fire less often. Armored formations may move more slowly. Reinforcements may arrive later, while Crimea and the southern front receive fewer supplies than planned. Ukraine is therefore testing the strength of Russia's recovery system, not only the strength of its bridges. The decisive issue is whether Moscow can restore movement across the wider network before Ukraine finds the next weak point and strikes again across land, rail, and sea routes under pressure. War is not only decided by weapons and battlefield victories. It is also shaped by logistics, political choices, and the human cost paid when supply lines become military targets. Understanding these systems helps us see why wars continue, how they can expand, and why serious diplomacy remains essential to building lasting peace. Subscribe to Military Force for clear analysis of the weapons, strategies, and political decisions shaping today's conflicts.